Good morning to all. Today we shall discuss about an adaptive method for resource allocation in cloud computing environment. Cloud computing has been regarded as emerging approach for provisioning resources and managing applications. Nowadays, cloud computing is broadly used in variety of domains and applications. It provides many attractive features like on-demand model, scalability enhancement. Whenever we want to scale up our business, it provides very good support and operational cost reduction and convenient access. So service providers, what do? They establish their own data centers. They invest huge to maintain hardware, software, and applications and provide services to users. They provide user-friendly services for minimum cost to deliver 24/7 and all 365 days access to the resources and applications. You can access the resources and application from anywhere at any time. So it is called as pay-as-you-go method. Types of cloud computing. Or we can say it as a deployment models. So there are 4 types of cloud computing: private cloud, community cloud, public cloud, and hybrid cloud. So private cloud means the cloud infrastructure will be operated within an organization. So it is private to the employees, those who are working into that organization. No one else from the outside can access that cloud infrastructure. And community cloud means the cloud infrastructure will be shared by several organizations who share the common goal, or there will be a specific goal. So those organizations will be sharing the cloud infrastructure. And public cloud means the cloud infrastructure will be available to general public. Anyone can access that cloud infrastructure. And hybrid cloud means the cloud infrastructure is the composition of 2 or more clouds. That is, we can combine private cloud with public cloud, or private and community cloud, or combination of all the 3. So when we'll be going for this hybrid cloud, for example, we are having private cloud, and at specific situation, there won't be enough resources. So what we do at that particular time, we'll be getting extra resources from the public cloud. So we are combining both private cloud and public cloud. That's why it is called as hybrid cloud. And here we could see, so there are different services provided by Amazon Azure, Amazon Microsoft Azure, Amazon Web Services, IBM Blue Cloud, Google App Engine, Salesforce.com. So these services are provided to the public through internet. And if you come to this private cloud, IBM C2. So it is operated within an intranet, within an organization. When there is insufficient resources, we'll be getting the resources from the public cloud. So we'll be combining both hybrid public cloud as well as private cloud. That's why it is called as hybrid cloud. And whenever there is a request from the user, would happen, it will be put into the cloud service queues. And in the data center, there will be several virtual machines and physical machines, and cloud storage will be available. So that will be given to the users as per the queue, service queue. So those who given the services request first, they will be granted first. So it will be provided from the data centers. And next is cloud service model. So there are variety of services are provided by cloud computing environment. So on the whole, we can say there are 3 types of cloud service models. That is infrastructure as the service, platform as a service, software as a service. Apart from this also, security is provided as a service, data is provided as a service, and we can say security data, and then anything can be provided as the service. So first, infrastructure as a service. So what we do here in infrastructure as a service, we'll be provisioning the processing, storage, network, and other fundamental computing resources as the service. And platform as a service means we'll be providing the platform where the customers or consumers or clients can build their own applications. They can create their application upon the platform what is provided as the service. So for building their own applications, we'll be providing programming languages, libraries, services, and tools supported by the provider. And then if we come to the third level, that is called as software as a service. So here what we'll be doing, the softwares will be built by the providers, and that application will be given as a service. And that software is built and given as the service to the clients. So they can access this application from anywhere at any time from various client devices. And here, if you see, I have given the diagram how the virtual machine is created. So in a physical machine, there will be a hardware, right? And there will be operating system. Upon that, we'll be installing the software hypervisor. This hypervisor is otherwise called as virtual machine monitor. So when you install this hypervisor, we could create different virtual machine as per the specification of the physical machine. So in each virtual machines, there will be an application and OS, operating system will be there. This OS is called as guest OS, and the OS present in the physical machine is called as host OS. Okay, so in a physical machine, any number of virtual machines can be created as per the specification or capacity. So here there are 3 virtual machines. In each 3 virtual machines, there is separate OS and separate application is running. So in that cloud computing service provisioning, there are some problems we face. That is hardware failures. Sometimes we may face the problem of hardware failures, and we face the problem of overload due to unexpected workloads. Okay, and the wastage of energy due to insufficient resource utilization. So here I would like to give some more explanation on this wastage of energy. So for example, there are 2 physical machines. One physical machine is capable of creating 5 virtual machines, and another physical machine is capable of creating another 5 to 10 virtual machines. So here in the first physical machine, so if you want to give the request from the client, we can give up to 5 services can be granted from that first physical machine. If you take, there are 4 requests from the user. So you can allot 2 virtual machine from the first physical machine, and if you are allotting another 2 virtual machine from the physical machine 2, means unnecessarily we are wasting the energy, because physical machine 1 itself is capable of providing 5 services to the clients. Okay, so already there are 5 virtual machine available in the physical machine 1. Then why want to switch on physical machine 2? So if we unnecessarily utilizing the resources inefficiently, then automatically we face the problem of wastage of energy. So these all result in resource shortages and application issues such as delays or saturation. So brownout is the promising approach for adaptive management of resources and application in cloud computing environment. So brownout. So it's a paradigm. What it does, it enables or disables optional part in the system to handle unpredictable workloads. The idea behind the brownout paradigm is to be adaptive. So here the optional parts will be temporarily deactivated so that the essential function of the system can be granted. Okay, deactivating certain optional function can contribute to increase in the request acceptance from the customers. So brownout, it makes the system very adaptive to the changing workloads. So there will be a dimmer. In that, there is a control knob. What it is, it takes the value from 0 to 1 to represent the probability of running the optional parts and to manage brownout activities in the system. So this is the architecture of the brownout approach. So here we are having MAPE feedback loop control. So here there are phases like monitoring phase, analyze phase, plan and execute phase. And also knowledge phase is there. So we are going to combine this MAPEK loop with the cloud computing system with using sensors and actuators. So here the knowledge module, it has the whole system description. So it gives the decision to other phases what it has to do. It triggers the operations in the other phases. And monitoring module, what it does, it collects the data from the sensors and monitors system status continuously. The collected data are transferred to the analyze module. In analyze model, what we do, we use different methods to analyze the data which is received from the monitor module, and it will be passed on to the planning module. In the planning module, what we'll do, we'll plan as per the workload fluctuations. An execution model will be implementing the plans. So the main role here is we have to ensure the specified system requirements. So in addition, these actuators are used to trace new challenges, and as per the challenges, the decision will be taken from the direction of the knowledge pool and it will be executed. So here it is the brownout approach for adaptive management in cloud computing system. So here what we do will be provisioning application as well as resources, right? So this adaptive management of resources is divided into 5 phases, like application design, workload scheduling, monitoring, brownout controller design, and metrics. So these phases can be mapped to MAPEK modules. So here this application design and workload scheduling is mapped with the knowledge module. In that we have seen now here. So it is mapped with the knowledge module. And then monitoring is mapped with monitor module in the MAPEK loop to monitor the system status. And brownout controller design is mapped with analyze, plan, and execute modules. And matrices are mapped to the information obtained from the sensors. So here, if you take application designs, these applications run in the cloud computing system to provide services to the users. So it can be further divided into different modules. So here, application type, application domain, optional parts, and application deployment. Like that, we can divide. So if you come to this application type, there are 2 types of application: desktop application and web related applications. An application domain means it is general or it is business oriented. So what type of application we are going to do, that we have to decide here. And optional parts can be a content or components or containers. So what we are going to use as the optional part to our application, we have to decide. An application deployment, where we are going to deploy our application in physical machine or in virtual machine, that we have to decide. And workload scheduling. So here workload scheduling aims to schedule and allocate appropriate resources which is suitable for the workloads according to the SLA. SLA means is a service level agreement. Before provisioning any services between the provider and consumer, they will be signing in the agreement that is called a service level agreement. So in that agreement, they will be specifying whatever features they need. Okay, that will be specified and it will be agreed by both the parties. That is called as a service level agreement. So this workload can be executed very efficiently and application utilize the resources also efficiently. So this workload scheduling can be further divided into workload type, resource type, dynamicity, and workload trace and experiments platform. So here, if you take workload type, we have to see which type of workload type, that is CPU intensive do we need or network intensive, and resource type, is it homogeneous or heterogeneous resources we need for our application. And dynamicity means is it online or offline. So if we know the amount of resources needed previously, means that is called as offline. But if we don't have any idea about resource requirements, means that is called as online. At the time of execution only, if you come to know, that is called as online. Otherwise, it is called as offline. And workload trace, are we going to use the real workload or synthetic? That we have to design. And then experiment platform, are we going to use real testbed or some simulation tool? That we have to see. So here I would like to give you some orientation about the simulation tool, that is CloudSim. Okay, it is an open source tool used for simulation, and it is generalized and extensible simulation framework which allows seamless modeling and simulation and experimentation of evolving cloud computing infrastructure. It offers many features like supporting for modeling and simulation of large-scale cloud computing environments. So here it includes the data centers, computing nodes, etc. So it gives the platform for modeling cloud service brokers, allocation, and provisioning of resources. And it supports for simulation of network connections, and it provides the facility for simulation of federated cloud environment. So here, this is the CloudSim simulation flow. So first we'll be initializing the CloudSim simulation and we'll be creating data center. After creating data center, we'll be creating data center broker, and then we'll be creating virtual machines and cloudlets, and it will be added to its respective list. After that, what we'll do, we'll submit this virtual machine and cloudlet list to the broker, and we'll start the simulation. After that, we'll be stopping the simulation, we'll print the result. So here what is happening, this is the data center. In the data center, there will be a storage and there will be a number of physical machines, that is called as host machines. So in that host machine, there will be a number of virtual machines. Okay, and then the data center will be giving the information about the resource availability to the cloud information service. And the broker will get the information about the available resources from the cloud information service. So the cloudlet means the task, okay, our workload that will be submitted to the broker. So broker will get the information from the cloud information service. After that, they will be forwarding their cloudlet to the data center where the resources are available. And the request will be processed and it will give the result to the broker, and that will be passed to the customers. So this is the flow in the CloudSim 2. And I have tested for some 100 times. I have taken some random cloudlet and tested in the CloudSim tool. So I have taken, this is the basic configuration. I have used CloudSim 3.0.3 simulation software, and I have used in a Core i5 processor, and this is the configuration of the system where I have tested my algorithm. And here I have used the shortest job first scheduling algorithm to test the result. And here the simulation run was repeated 10 times using the parameters. That is cloudlet, I have taken 10 to 90, and virtual machines as per the number of cloud loads I have created. And I have used one data center, and I have used the cloudlet in a heterogeneous cloudlet. Okay, so here I have tested the performance using shortest job first scheduling and round robin scheduling. Since this round robin scheduling is the default algorithm used to schedule the workload before submitting to the virtual machine for processing. So here, this is the performance I have got. I have checked for this wall clock throughput, CPU throughput, and makespan. Makespan is the completion time. So this is the result I got. So if you see in round robin method, you see there is a equal number of CPU is utilized for executing the cloudlet. But if you see at the starting only it was high, then as per the cloudlet it is getting utilized, the CPU time is getting utilized, so the performance is getting improved in the shortest job first scheduling algorithm compared to round robin method. So thank you.